Dear student, in this lecture we are going to discuss about a galvanic cell. Galvanic cell is known as Voltaic cell. Galvanic cell is a cell which is used to convert a chemical reaction into an electricity. So galvanic cell produce electricity due to chemical reaction. In galvanic cells, there are usually occurs two types of chemical reaction. One type of chemical reaction is known as oxidation reaction, whereas second type of chemical reaction which occur in a galvanic cell is known as reduction reaction. In oxidation reaction of galvanic cell, suppose this is an atom A and this is an atom B. The electrons are transferred from atom A into atom B. So the electrons are given by an atom A. So this the reaction at atom A is known as oxidation reaction. Whereas in case if two atoms, suppose C and D, electrons, if they are given by an atom D to an atom C, so electrons are basically gained by atom C. So reaction which is taken place at atom C will be known as a reduction reaction. So these are basically two types of reactions which take place in a galvanic cell. And due to the oxidation and reduction reactions in galvanic cell, there will occur a flow of an electron from one side of a galvanic cell into the other side of the galvanic cell. The flow of the electron is basically known as a current. I is equal to flow of the charges. Here the charges are electron. The flow of charge per unit time is a current, and hence an electricity is generated by due to a chemical reaction in a galvanic cell, by a chemical reaction which is taken place by on its own. The electron which are basically flowing in a galvanic cell are channelized by a wire, and the wires basically are connect the two parts of the chemical in which chemical reaction take place, and due to the conducting wire, electron basically start to flow from one side of the chemical reaction to the other, and hence the flow of the charges basically will produce an electric current. Now, dear student, let us discuss the construction of a galvanic cell. Galvanic cell basically consists of two containers. Container A, this is container A, and container B. Usually, zinc sulfate and copper sulfates are used in a form of solution in a galvanic cell. There are different other types of solutions, polars or ionic solution, which may be used in galvanic cell, but most commonly, galvanic cells are based on zinc sulfate solution. Suppose this is zinc sulfate ZnSO sulfate based container, whereas container B, usually we are discussing zinc sulfate and copper sulfate based galvanic cell, so it will be consist of CuSO4 solutions. So suppose that this part of a galvanic cell consists of is copper sulfate solutions. Galvanic cell consists of electrodes, and these electrodes are known as cathode, which is which is made up of a zinc, pure zinc metal, and it is present in a zinc sulfate solution. Whereas the other container of a galvanic cell consists of an electrode, which is usually an anode, and it consists of an anode, and it is made up of copper Cu metal. The solution of a zinc sulfate will consist of ions. Since we prepare a zinc sulfate solution or in galvanic cell, zinc sulfate solution is prepared in water, so it will consist of zinc Zn2 plus ion, SO4 minus 2 ion, Zn2 plus ions, SO2 minus ion, Zn2 plus ion, SO4 minus 2 ions. Similarly, the copper sulfate side of a galvanic cell will consist of copper Cu2 plus ions, SO4 2 minus ion, Cu2 plus ion, SO4 2 minus ion, Cu2 plus ions, and SO4 2 minus ions. So this will be an ionic distributions of copper and zinc in the solution of a zinc sulfate and copper sulfate of part of the galvanic cell. The cathode and anode of a galvanic cell are usually connected with a conducting wire, with the conducting metallic wires like this. The role of conducting metallic wire is very important. The conducting wire basically channelizes the flow of the electron from a cathode to the anode, and due to channelization there will be a production of an electric current and electricity. Dear student, please keep in mind that the copper atom has a stronger pull of electron than a zinc. So electron pull of a copper is stronger than zinc. And please keep in mind that usually the ions which are present in a solution are not stable, they are very active. So the copper has 2 plus ions, and it has a stronger pull than the zinc. Then the copper will say to the zinc, oh, I need few electrons, can you give me these electrons? Since you know that the zinc has a weaker pull than a copper, then zinc will start to give an electron to the copper. So due to this, the electron from the zinc will start to flow. and they will go toward the copper plate. And due to the flow of the electrons, as you know that current is basically, it is a flow of the electron, it is the flow of the charges per unit time. Since charges here are electrons, so it will be a flow of the electron per unit time. Due to the pull, heavier pull or higher pull of the copper, the electron will be channelized through a wire and they will go toward the anode part of the galvanic cell. And due to this, an electricity will be produced in galvanic cell. So this is an overall construction of a galvanic cell. So now, dear student, let us zoom the construction of the galvanic cell and discuss that how and what type of chemical reaction take place and how different types of reductions and oxidation reaction will take place, due to which an electricity will be produced in a galvanic cell. Let's reconstruct this galvanic cell again. This is container A of the galvanic cell solution. This is container B of the galvanic cell solution. So it is made up of a zinc sulfate, so it will consist of Zn2 plus SO42 minus Zn2 plus SO42 minus Zn2 plus SO42 minus. For simplicity, let's consider that for simplicity, don't consider SnO4. We just considered here. We just consider, like, suppose this solution has just zinc Zn2 plus ions. This is just for simplicity, okay? We suppose that this container has Zn2 plus ions, and later we will discuss that how what will be the role of SO4 ions. So on the other side of the container of galvanic cell, there will be an ions of a Cu2 plus and SO4, but here just for simplicity we represent that it consists of Cu2 plus ions, Cu2 plus ions, Cu2 plus ions. Now both the container of the galvanic cell are made or consist of cathode, consist of an electrode, and one side of the galvanic cell, or one part of the galvanic cell, which is usually based on zinc, consists of a piece of a zinc metal, and it's act like a cathode, whereas the other part of the galvanic cell is made up of a piece of a pure metal of positively charged anode, and the anode is made up of copper metal. Both these are connected with a conducting wire. Suppose this is a conducting wire to channelize the flow of the electrons. Now if we zoom these two part or two container of the galvanic cell, as you know that the copper has a stronger pull than a zinc for an electron. So the electron from the zinc will start to flow from copper metal, from zinc cathode toward anode. It will be electrons. So the flow of the electron from zinc cathode toward the copper electrode will produce a current, and current is for charge ratio time, for charge per unit time. Charge here is electron, so the flow of the electron per unit time will be an electricity. So electricity will be produced due to a flow of the electron from zinc cathode toward the copper anode. Now, interesting point here to notice is that when an atom, suppose zinc, give 2 electrons, then zinc atom will be converted into zinc ion, Zn2 minus, Zn2 plus. So zinc basically here is converted into an ion. Zinc has given 2 ions, 2 electrons, and zinc is basically, this zinc atom is basically will be shifted or will be converted into zinc 2 plus ions. Please keep in mind that ions are not stable on the metal plate. They are soluble in solution. So the zinc ion will be transferred into zinc sulfate solution. So zinc ion from the metal will be transferred and will jump from a zinc metal into the zinc sulfate solution. Whereas copper, Cu, is basically, copper ions are stable in a solution, but electrons are basically from a zinc zinc side of the zinc Zn4 are basically transferred toward the copper anode. So the electrons will come through the copper anode, they will connect with copper Cu2 plus ions, and due to this Cu2 plus will be converted into Cu, neutral copper atom. So neutral copper atom is stable copper atom, and it will be fixed, or it will be connected with the anode of a copper atom. So this means that when the electrons are reduced, or when electrons are removed from a zinc metal, the zinc atom will be converted into zinc ion. They will be transferred into a solution, and they will be removed from a zinc plate. So the size of the zinc plate will shrink. Whereas on the other side, copper is gaining electrons. So the size of the plate of the copper will increase. Okay. Now, on this side, zinc is basically losing electron, is giving electron to a copper. So the chemical reaction which will take place will be oxidation reaction. Whereas chemical reaction on the right side, where there is a copper solution, is basically copper is gaining electrons, so the chemical reaction on the copper side will be reduction reaction. Both these chemical reactions may be represented by equations as, since zinc side of oxidation reaction, since zinc atom which is in a form of a solid is losing 2 electron, is giving 2 electron, then zinc will be converted into Zn 2 ion. Zinc is not stable in a metal form, zinc ion, so it will be a part of a solution of Zn4, plus it will have will will give 2 electrons. So the zinc side of the galvanic cell, or zinc part of the galvanic cell, there will be an oxidation reaction, whereas on the copper side there will be a reduction reaction. Reaction copper Cu2 plus ions are basically gaining 2 electrons from a zinc. Copper will be initially, which is will be unstable in metal form. It will be a part of CuSO4 solution. When it gains 2 electron, copper will be converted into Cu atom, and it will be a part of a solid copper anode. So the copper sulfate side of the galvanic cell will be feel, or will do a reduction reaction. So both the zinc sulfate and copper sulfate, both these two reactions are known as half reactions. Why both these reactions are said half reaction? Because these are basically a general representation of half side of chemical reaction of galvanic cell. So now, interesting point to note here is that galvanic cell a consists of another part which is known as a salt bridge. So now we will explain galvanic cell as a whole, that what is the role of a sulfate in a solution of copper sulfate and zinc sulfate, and what is the role of a salt bridge in a galvanic cell. So that will be a whole picture of a galvanic cell. So now let's explain a galvanic cell on the basis of a whole picture. As I previously discussed, galvanic cell consists of two solutions. Usually two containers. One type of container is usually based on zinc sulfate, whereas the second container of a galvanic cell is based on CuSO4 or copper sulfate. These are connected with metallic cathode and anode, which is made up of a copper metal, whereas cathode is made up of a zinc metal. Both these metal copper cathodes are connected with a conducting wire, and the role of the conducting wire is to manipulate, is to channelize the flow of the electrons between the cathode and anode. Now, since zinc sulfate will consist of Zn2 plus ion sulfate, SO2 minus ion Zn2 plus, SO4 2 minus Zn2 plus ions, SO4 2 minus ions. Similarly, copper sulfate solution will be consist of Cu2 plus ion, SO minus, form 2 minus ions, Cu2 plus ions, SO4 2 minus SO4 2 minus ion, Cu2 plus ions, SO2 minus ions. So now both the parts of the galvanic cell are connected by a part, and it is known as salt bridge. Salt bridge connect the part A of the galvanic cell with a part B of a galvanic cell. Dear student, now as you know that the copper has a stronger pull than a zinc for an electron. So due to this, electron from a zinc will start to flow from zinc solution toward the copper solution, and due to this they will generate an electricity. So now when electrons are moved from a zinc to the copper solution, the zinc will, as the zinc atom is basically giving electron to the copper solution. So the zinc atom in the form of ion Zn2 plus is not stable with a plate of a cathode, the zinc metal. So it will jump from a zinc metal into the solution of a zinc sulfate. Similarly, huge amount of a zinc 2 plus will be produced on the zinc sulfate side of a galvanic cell from the metal of a zinc. Okay, whereas copper is basically solution part of copper sulfate part of a solution is gaining electron, it is achieving electron. Due to this, copper sulfate Cu2 plus is basically is gaining two electrons from here. So like electron will jump and they will interact with the copper, and copper will be copper ion will be converted into a neutral copper atom. So the neutral copper atom is not stable in a solution, so it will be connected with a copper plate. So the number of copper Cu2 plus will be decreased, and whereas the number of the zinc are here on the other side, A sides are zinc ions are increasing, and number of copper ions are decreasing. So since if the zinc ion on the A side of the galvanic cell are increasing, this means that there will be electronic imbalance of charges at a zinc sulfate side or A side of a galvanic cell. Similarly, the ions from the copper are basically changing or converting into copper atom, and they are becoming a part of a copper plate. So here will be a charge imbalance on the copper sulfate side of the solution. Due to this, the imbalance between the galvanic cell is created. Imbalance of the electric charges in a galvanic cell is created, and this will basically deteriorate, or this will destroy the efficiency of a galvanic cell. In order to maintain an efficiency, salt bridge is used. Salt bridge consists of positively is made up of sodium chloride solution, which consists of positively charged sodium and negatively charged chlorine ions. And the head or the end of the of the salt bridge is connected with a cotton. Okay, so the small amount of the ions from the salt bridge will be transferred into the solutions of copper sulfate and zinc sulfate. So the positive and negative ions will be transferred into a solution, and due to this, a balance of the charges at the A and B side of solution of the galvanic cell will take place, and due to a balance of charges, the efficiency of a galvanic cell will be increased. So the role of the salt bridge in galvanic cell is just to maintain a charge balance in a galvanic cell. So this is basically the student's overall picture of a galvanic cell. Galvanic cell is a device which is used to convert a chemical reaction into an electricity. Galvanic cells are also known as voltaic cells. In galvanic cells, there are two types of chemical reactions. One type of chemical reaction is known as oxidation reaction, and second types of chemical reaction is known as reduction reaction. So both these oxidation and reduction reaction take place in two different parts of a galvanic cell. And due to oxidation and reduction reactions, there will be a charge flow through a wire which is connected with the two parts of a galvanic cell, and the charge flow or the flow of the electron through a wire in a part of the galvanic cell will produce an electricity. So this is all about the galvanic cells. Thank you for watching this lecture.